Okay, well now we're going to go into kind of the idea behind the analysis of variance. The analysis of variance was created by a gentleman, very famous statistician, if there are famous statisticians, called Fisher. And so instead of getting a t-score at the end, we get an f-score at the end. That's a little different than students thinking that if they fail miserably on something, the F stands for a failing grade. What I'll need you to do for this particular recording is pull up the ANOVA picture file. I'm a terrible artist. My wife is actually a professional artist, but I basically made this picture file to kind of represent the situation at hand with our drug versus no drug situation. And what I basically drew here is I've got the figure here showing that the 3 people in the no drug condition, you can see the 1, 2, and 3, the 3 people with the drug, the 5, 6, and 7. When you do an ANOVA, you get an F score. And if you look at the very top of my sheet of paper there, you can see that to get an F score, you basically have to compute 2 things. You have to compute the variance between group, and then you have to compute the variance within group. And the question is, well, what is the variance between group and what is the variance within group? The variance between group really represents that red line that I drew. The variance between group really reflects the treatment effect. It's the variance between the 2 and the 6, the means of the 2 groups. So the variance between group really reflects the mean difference, and it's what you remember from the t-test as being kind of the treatment effect. The denominator, the variance within group. The variance within group reflects the spread of scores within each group. So if you look at one group, you have the 5, 6, and 7. The variance within group reflects the spread of those scores. The variance for the no drug group reflects the spread of scores within the 1, 2, and 3. And once again, you want, for any one group, you hope that their scores are very close to each other, so we want that to be low, because that's going to reflect kind of the idea of error. So the variance within group we want to be low, the variance between group we want to be large. And if you go back to the outline, we actually know a few basic things under C as far as F scores are concerned. The question I would ask you, let's say you do a computation and you get an F score of 1. Would that be good news or bad news, do you think? An F score of 1. Well, hopefully what you figured out is that if you get an F score of 1, the variance between groups is actually equivalent to the variance within group. And by the way, page 393 and 394 reflect this a little more in your book. So the idea is if you get an F score of 1, the variance between groups equals the variance within groups. This is actually not good news. This means that your treatment effect is basically equivalent to your error. If the numerator is treatment effect, then the denominator is error. So an F score of 1 would not be good news. What if you get an F score less than 1? What would that mean? Well, that would mean that you have more error than treatment effect, and that would be really bad news. So those 2 results, 1 and 2, would not be significant. What we really want when we run our ANOVA is we really want results where the F score is much larger than 1. We want to get it where the numerator is quite large with a large treatment effect. We want to get a denominator that's very small. So we want to get, when we do these F scores, scores greater than 1. So I hope that makes sense. Page 393 and 394 of your book should make more sense. The picture hopefully does the job. The idea is we want the variance between groups, the difference between the 2 and 6 to be quite large. Or between the 2 group means to be large. We want the variance within group to be small. That's going to give us a large F ratio. So that'll conclude this lecture. Thank you. Bye-bye.